My name's Dr. Barry Flannery. I'm the founder and CEO of Zerotech. Welcome to XT Tech Talks. Today we're going to walk you through the scalability and the fundamental design of our Hibernium battery system. So let's get started. The most important thing to understand with battery packs in today's market is that they need to come in all different shapes and sizes. And that's where our scalability is such an important piece. When you consider all of the equipment that exists out there in very diverse, low volume applications, from ground service equipment to an excavator to a dump truck to an aircraft or a marine vessel, these come in a very wide range of shapes, sizes, footprints, and power requirements. So I guess in the most simplest terms, all of this equipment exists in today's world because there was a diesel engine catalog that you could pick out of to power that machinery. That catalog doesn't exist today for batteries. So instead, you've got to build a very scalable and flexible system instead. That's where the Zerotech Hibernium system really comes into its own. We have a fundamental architecture that's got hundreds of different shapes and sizes. And what that means is, no matter what your vehicle is, what the footprint that's left inside of that vehicle, once you take out a diesel engine and the rest of the driveline, there's a good chance that we can fit a battery inside of that space and meet your requirements. So when we think about a battery from an end user perspective, there's really only two attributes that people really care about. That's going to be the voltage and the capacity of that battery pack. So the voltage, it'll be potentially a 400 volt pack or an 800 volt pack or a 660 volt pack, or anything in between, depending on the end user application. And the capacity, or its energy content, is simply going to be, is it a 10 kilowatt hour pack? Is it 100 kilowatt hours? Are there multiple packs in the system? Could it be 1 megawatt hour? This is what matters, because depending on the size of the machines you have, they might only need quite a small pack, or they might need dozens of packs inside of it, like a large rail application or a huge mining dump truck. So in order to meet all of these system requirements, you've got to design your battery pack in a very particular way. Most of the market today for the lithium-ion battery space, it's focused around 1 or 2 battery packs. Most suppliers of battery systems have basically built 1 or 2 key packs, and they'll then stack those packs many times to try and meet these requirements. The problem with that is, for most players on the market today, they've made a decision that we're going to sell a 50 kilowatt hour battery pack or an 80 kilowatt hour battery pack. And that basically means they can only offer you a multiple of those numbers, or maybe they have 2 packs. The difference with Zerotech and our Hibernium battery system is that we've got hundreds of different individual permutations. So that means we've got huge flexibility. So I can get you anywhere from 10 to 300 kilowatt hours in very regular steps in between across a wide range of voltage. And the way we're doing that is a very scalable module, some of which you can see beside me here today. So the fundamentals of how we do that is using our scalable separator plate design and our scalable module. So when we talk about a battery pack and scalability, fundamentally we're just adding more and more battery cells in series and in parallel to build up our module. So the goal here is to find a most useful size of module that can be built up into a pack which has got multiple modules inside of it. So the way we build our modules is we scale on individual units or battery cells, and we physically have 16 cells across, and we increment in units of 6 cells going in this dimension. What this looks like in our separator plate, which, as the name implies, separates the battery cells from each other, this will hold the cells like so. And then we can increase the size of this module by adding more and more repeating elements to each other, up to a maximum of 7 lengths. So that gives our biggest module 7 blocks of 6 across. So 42 cells across the way. So our modules are always 16 cells in one direction, 42 cells in another direction. And what's nice about our design is that these cells are being added in parallel. So we're able to increase the capacity of the battery without changing the voltage. So within our module, we scale up to the full size module, 42 across. And then the next thing we do is that our cell, or our module, has two different voltages. So with the bus bars, which I'll show in a moment, we're able to have 8S or 16S configuration. And S means series cells, so the cells are connected in series. And we're doing this through a very simple bus bar design that runs along the length of the module. So these modules are able to grow in parallel capacity without altering the voltage. So as we discussed at the start, we're able to extend our modules in blocks of 6 cells, adding more parallel capacity. And then we've got 2 voltage classes by going along the length of the bus bars here in either an 8S or a 16S configuration. The module shown here is an 8S, which means there's 8 cells connected in series. So basically it means that the module is around 30 volts. We can also split these bus bars along their length here into a 16S configuration, which gives us around 60 volts of voltage. So by being able to have lots of different lengths of module, that gives us quite a lot of variation in width here, or capacity. And then by being able to switch to multiple voltages within a module, it gives us further flexibility. The final step on our scalable pack is the fact that we stack the modules on top of each other to build up a full pack. So we can stack up to 24 modules in series with each other to achieve very high voltages, up at nearly 1000 volts DC, and in fact higher voltages are now possible. So if we're to take a look at the core architecture, we've got a module that comes in 6 lengths. It's basically 12, 18, 24, 30, 36, and 42 cells across. Our modules are always 16 cells long or wide on the module here. So we've got individual variations here across the architecture. The reason we've chosen these numbers is that they're good even numbers, and it makes it a lot easier to do your bus bar configurations and your cell voltage configurations. That's why it's very important on the number you choose for your scalability. The second thing we can do is that we've got 2 voltage classes. So we've got 8S and 16S. Again, these are even integers of 16, and that's important as well because it means we can break up our bus bar along the length here. So we can split the bus bar, just cut it at the different module lengths without impacting any of the voltage configuration. We can just have a parallel connection of our modules. And then to do an 8S configuration, we basically just make the bus bar twice as wide, and that achieves a lower voltage on the module or higher capacity. So by going in an 8S configuration, that will make your module, in this case here, it will be 8S, and it's 12 cells with 2 in parallel. It'll be 24p. Or else alternatively, we've got a 16S 12p. And as this goes up through our scales of modules, you'll have a 16S 18p, and similarly an 8S 36p, and so forth all the way up to our biggest module. So this gives you a lot of flexibility and scalability within the module before we even start talking about packs. And our pack stack up is what we'll talk about next. So now you can see how the modules we offer can come in different lengths, all based on a fundamental common building block, which is our separator plate, which we scale incrementally to build different lengths of modules by increasing the parallel capacity of cells. Once we stack these modules on top of each other, we're able to build up more capacity and more voltage. So once we take our fundamental building block, we're basically able to stack these modules directly on top of each other. So this is taking an individual module, which could be a 16S 24p module. So this one in this case might be 24 cells long. and then we're stacking it on top of other modules to build up an entire pack system. The important thing with our design is that the modules must be all the same number of parallel cells. You can't put a pack with different parallel cells in series, or it results in very large imbalance. So once we stay within one module family, so we pick one of the 6 modules that we offer on our platform, we can then stack the modules up to a total of 24 modules in series. So this can result in quite large packs, nearly 2.5 meters tall for our largest systems. And that's fundamentally the limit of why we don't go larger than 24 modules. Electrically and other factors, we can go more, but the systems become simply too large to manage, to handle. And there's other considerations like sheet metal sizing and many other factors. So this module platform, you've got 6 widths of module. That's our 12, 18, 24, 30, 36, 42. And we've got 24 lengths of pack. So what that ultimately means is the Hibernian platform is a box that has lots of different widths being driven by the modules, and then it's got lots of different lengths being driven by the number of modules stacked in series. So you're increasing the voltage by going this way, and you're increasing the capacity by going this way. And we've also got the dual voltage module, which enables us to have different voltages within this configuration. The end goal of all this scalability, why all this stuff matters, is we have a lot of different boxes that can fit inside of a space claim. And a space claim is basically the amount of space left inside of a system after you take out the engine and the rest of the transmission that's in there. This is one of the biggest challenges in the markets that we operate in, is that they're very low volume. So it's often not possible to engineer a specialized pack just for that machine, because they might only ever build a handful of machines or even a few hundred. And this just does not make sense for a battery pack development program. It's too expensive and it takes too long. So what's very interesting about the Hibernian platform is that we don't care if you buy one pack for your one machine. It's all coming off a common platform, common building blocks. So you basically get all of the economies of scale and the efficiencies of this entire platform, even if you yourself, for your application, only ever buy this pack or this pack. You get the benefit of every other customer that we sell to who's buying packs over here and here and here. All of these together drive down the cost of the platform. It enables you to buy battery packs at a price and an availability level that would traditionally only be available to automotive OEMs. So now that we've talked about the scalability of our module, the scalability of our pack, changing the size of the white box, we can now talk about the scalability of our system. We're able to stack multiple packs together in parallel, and in some cases in series. In theory, there's no limitation for how many packs we can put in parallel, but a practical system limit that we've done ourselves is probably about 40 to 60 packs. And that can result in absolutely huge energy storage systems. Some of the largest systems we've developed to date are nearly 10 megawatt hours in one mobile application. So these are larger than some very large energy storage systems or containerized ESS, but they're mobile, which introduces a lot of different requirements. So why is scalability so important for an end user? The key thing about scalability is that it lets you avoid NRE, or non-recurring engineering. And what that is fundamentally is you don't want to be paying someone to custom design one battery for your one machine. You might be making hundreds of different machines and have a very wide platform. And that's the goal for Zerotech, is we are a platform provider of many different shapes and sizes of battery system. We may not have a solution for every one of your applications, but we almost certainly will have more answers than anybody else on the market today. And that's critically important. A platform solution is the only solution for the off-highway, low-volume, high-diversity market. And that's how we're enabling electrification. The reason platform scalability is so important on today's market is that the first wave of electrified off-highway vehicles, it's built on what's called legacy platform. Legacy platform means this machine was built with a diesel engine in mind. A diesel engine was picked from a catalog potentially decades ago, and then a machine was built around it. Once you take out this engine and whatever else is around it, you're left with a very specific shape, size, and footprint. It's probably a blocky concept, and that's a big part of the reason why the Hibernian platform is a blocky concept. We're not focused on automotive passenger vehicles, which are traditionally a very flat, low-profile skateboard design. Instead, we're filling the space left by a large diesel engine, probably in an industrial machine. So this approach enables you to retrofit into legacy designs very easily. And if you have the opportunity for a clean sheet design, it means that you can build from the ground up around our platform. And a blocky, prismatic shape of an overall system, that is the optimum for a battery system. So you'd want to design your machine around our common catalog of what's available in volume off the shelf today. So that was a very quick overview of the scalability of the Hibernian platform. Thanks for watching.